All right, guys, welcome to our beginning of the trigonometry unit. It's going to be a very, very short unit of just 3 days of notes, and then we'll take a quiz over it. Let's go ahead and start with trigonometry. First thing I'll talk about with trigonometry is what we call the angle of perspective. This is also known as a reference angle. Okay, so we can write in here, you'll hear me call it a reference angle. Okay, make sure you're pausing if I'm going too fast. This is going to be the angle that you're basically standing at, and you'll understand this here in a minute, but it's going to be denoted by either the measurement in degrees or by what's called a theta. It's this little circle with a line through it. You might also see a question mark. You might also see an X, okay? This is going to tell you the location. The location of the angle is going to change which side is considered what's called opposite and adjacent, and that's what we're going to talk about here. This first also, before we move on, we need to remember that adjacent is a vocabulary word in geometry, and it's very, very important. You need to remember this means next to. Okay, adjacent means right next to. So the first triangle we have here, let's find theta. This is our reference angle or angle of perspective. What ends up happening with you've got 3 different sides that you're going to have. You're going to have an adjacent, an opposite, and a hypotenuse. Well, your hypotenuse is always going to be located in the exact same spot across from your 90-degree angle. So here we have our hypotenuse. Now, your adjacent and your opposite, depending on where this angle, this reference angle of perspective is, we take a look and we see here that if we're standing right here at this angle, the side that is opposite of it, all the way on the other side, that is our opposite side. Makes sense, right? It's opposite. And then the angle that's right, or sorry, the side that is right next to it, that's not the hypotenuse is adjacent also, but it's the angle that's right next to it that's not, it's the leg, it's not the hypotenuse. This is going to be your adjacent. It is right next to the reference angle. So when we change locations of the reference angle, and you'll notice that in my notes and stuff, I always put this little arc right here saying that's my reference angle, okay? If we look at the other triangle, our reference angle has changed. So now our reference angle is up here at angle X. Again, your hypotenuse will always be in the same place. It will not move. So your hypotenuse is going to be crossing that 90-degree angle. But notice now that your opposite side is no longer XZ like it was over here. Your opposite side is now ZY. So here's your opposite. And then your adjacent right next to it is no longer going to be ZY, but it's going to be XZ. So they've just switched places. This will be your adjacent. When you switch reference angles, you switch the opposite and adjacent sides. Your hypotenuse never changes. Your reference angle will also never, ever, ever be the right angle. Ever. It's always going to be one of the 2 acute angles. So let's take a look at trigonometry. The names of the 3 most common trigonometric ratios are what we call sine, cosine, and tangent, and we do have abbreviations for them. These are your formulas down here. There is a term called Sohcahtoa, and that helps remember Sohcahtoa. So you have the sine of your angle is going to be opposite over hypotenuse. So now we're seeing these over here. So, literally so. To remember this, we have so, S-O-H, meaning the sine is your opposite over your hypotenuse. And we'll write this on the next page. Your cosine is adjacent over hypotenuse. So here, this is where ka and Sohcahtoa, C-A-H. Cosine is adjacent over hypotenuse. Cosine adjacent over hypotenuse. And your tangent does not involve your hypotenuse. It's your opposite over adjacent. So there's toa. So you have Sohcahtoa. And there's stories about it if you want to look it up. I don't know what the story is about, Indian princess and stuff. I don't know. But this is the term that's been used for years on this. So what we're going to do is these following problems here, we're going to choose which one of these formulas we're going to use, and we're just going to, right now on the front page, we're just going to set up the equation. Okay, when we get to the back side, we are going to actually learn to solve it, plugging into our calculator. And when we solve, we want to round to the nearest thousandths, which is going to end up being 3 decimals, or 3 numbers after the decimal. So we take a look at number 1. Let's find our reference angle. The reference angle, like it says, is either going to be an angle measurement or a theta or an X. So you're looking at inside the triangle, never the 90 degrees. Never, ever, ever choose that 90 degrees. So your reference angle is right here. So what we need to do is we need to figure out what two sides are we using. Well, right now I see across from the 90-degree angle, I see my hypotenuse. So I've got my hypotenuse, and then the other side is on the opposite side of the triangle, then this angle is not next to. So this will be my opposite. I'll just put OPP for opposite. So when we use opposite and we use hypotenuse, we look up here and we see that it's the SO. So what we can write here is the sine is equal to opposite over hypotenuse. Okay? And we just shorten it like this. So now when we set it up, we're going to have the sine of whatever the angle is equal to a fraction of the opposite side over the hypotenuse. So this will look like, and we write SIN, it's not called sin, it's called sine. Okay, in parentheses, we'll place whatever angle, whatever we have here for the angle, which is 59. Close the parentheses just like it shows us up here. We'll set that equal to a fraction of, we want opposite x over the hypotenuse, 16. And that's your formula. Okay, remember Sohcahtoa. And then again, we'll learn how to solve it. You're literally, other than setting it up, your calculator does everything for you in trigonometry. It's great. So here is your equation that we'll learn to solve in a moment. Let's take a look at number 2. We see here our reference angle is right here. It says 64 degrees. So let's see what sides we have. Across the right angle, I'm not using my hypotenuse. There's only one that does not use a hypotenuse. Okay? But let's take a look at what I do have. Across on the opposite side, I have my opposite. And later you're going to see me just using O's, A's, and H's. Okay? And then I have right next to it, but not the hypotenuse, it's a leg that's right next to it, I have my adjacent. So we look up at the top, we say, okay, what used opposite and adjacent? And we see here that it was tangent. So we have TOA. So here we can write tangent equals opposite over adjacent, TOA. And then just like with the sine earlier, now we're going to use tangent. So we'll take TAN, remember this is not tan, it is called tangent of, right in that angle, whatever it is, in this case 64. And we're going to set that equal to opposite, 23, over adjacent, x. And there's our equation. Next, number 3. Let's find our reference angle. It's up here at the top. Let's take a look at what sides we have. I have across from my 90-degree angle, I've got my hypotenuse. And then do I have my opposite? Nope, but I have my adjacent, the leg that's right next to it. So ADJ for adjacent. So we're going to look up here and say, okay, what uses the hypotenuse and the adjacent? Well, right here I have hypotenuse and adjacent. So we have Ka and Sohcahtoa. So this will be cosine is equal to Ka A over H, adjacent over hypotenuse. So we'll write COS for cosine, parentheses, put that reference angle of 53, all equal to adjacent, 13, over hypotenuse, x, and move to the next one. Then all we're doing is setting it up. Now, I purposely did this, okay? I have the same numbers on number 4. This one right here, we're still using this reference angle. It's still 53. We still have a 13 and an x, but the locations have changed, okay? The 13 did stay in the same place, okay? So the 13 is my adjacent. But now I have my opposite side also. So even though we have the same number and, same numbers and variables, we changed locations. Therefore, we need to look at what are we using opposite and adjacent. We look up here for opposite and adjacent. We find out it's tangent. So our TOA. So down here, we can write tangent is opposite over adjacent. TOA. So we have the tangent of the angle measurement, 53, is equal to opposite x over adjacent, 13. All right? So let's go solve. At the very, very top, before I get started, I'm going to write my Sohcahtoa in that fraction form that I was writing inside those triangles. we have Sohcahtoa. They're right there at the very, very top that I can take a look at. All right. So now we're going to find a missing side. We're going to write the equation, and then I'm going to show you guys exactly what to do. So when we're looking for a missing side, it's either you're multiplying or you're dividing. I'm going to show you exactly what happens here. When we take a look at the first one, again, let's do the setup. We got our setup. Here's our reference angle. Okay. I'm going to go a little quick on setting the equations up, right? I've got my opposite side all the way on the opposite side here. Okay, here's your opposite. And then I have the adjacent. I do not have hypotenuse. No hypotenuse. So this 15 is not a hypotenuse. It's going to be the adjacent. So opposite and adjacent, we're looking for O and A. And which one do we have O and A? Oh, it's tangent. Okay, so we're going to set up our equation as the tangent of 41, the angle, is equal to opposite over adjacent. So this is at TOA. Opposite x over adjacent 15. Now what ends up happening in every single one of these problems, and I'm going to show you a shortcut in a minute, what ends up happening is you're going to have to set up a proportion. We have a fraction on one side, we don't on the other. So we've discussed to turn anything into a fraction, we're simply going to place a 1 underneath it. And now we can cross multiply. When we cross multiply 1 times x, we're just going to get x. And then we cross multiply the other. I want you to pay very close attention to how I write this, so we do not put it in the calculator incorrectly. I'm going to write the whole number by itself first, and I'm going to put that one in front and say 15 times the tangent of 41, because I don't want to accidentally put it in the wrong place. Now, in the calculators at school, you need to understand every time that you get the calculator, you need to make sure you are in what's called degree mode. So when you have your calculator here, let me turn this little flash off, a little light off. We go into our calculator. You're going to notice up here next to the battery it says rad. Okay, that's radians. It's going to automatically default to that, especially when you clear your calculator. So you're going to take this little middle cursor and you're going to find your arrow. This is the easiest way to do this. You're going to go up there, you're going to highlight over it, you see it says radian, and then click that center button, bam, it turns it to degree. If it is not in degree mode, you will always get the incorrect answer. So that's the first thing you have to remember is make sure you are in degree mode. Okay? Now, turn this on so you guys can see the buttons later. When we do x is 15 times the tangent of 41, another very important button that you're going to be using is this button trig right here next to 7. Okay, your trig is going to give you more than what you need. We're only going to be using these first 6 on the left. Okay, but today we're only using the top 3. Okay, so what we're going to do, let me escape out of this, escape. We're going to type in now 15. Okay, and I'm going to push times. Go to that trig button, okay, and we're going to scroll over to tangent. Press enter, and you're going to see parentheses. That's where we type in the 41. Now you have exactly what is on the right-hand side. You press enter, okay. We did want to round to 3 numbers after the decimal, so we have 13. So this again, I'm going to show you that approximate sign. X is going to be approximately 13 point, let me move this a little bit out of the way, 0, 3, 9. That 3 at the very, very end tells me 4 or less, let it rest. That 9 is going to stay as a 9. So we're going to 13.039. And we have solved for that missing side using trigonometry. Okay? Let's do another one here. Number 2, my reference angle's up here. Let's figure out what sides I have. All right? Take a look. We've got across our 90-degree angle. I do have my hypotenuse this time. That's the one I always suggest you look for first, okay? So I do have hypotenuse, and then I have all the way on the opposite side. So we look at what has opposite and hypotenuse, O and H, and that's going to be sine. So we're going to have the sine, we're going to have SOA. Sine is opposite over hypotenuse. So let's go ahead and set up that equation like we learned. We have the sine of that angle measurement, 27, is equal to opposite 25 over the hypotenuse of x. Now, x is on the bottom now. We're still going to do the same thing. Watch. We're going to set it up like a proportion, okay, and we're going to cross multiply. This time what ends up happening is we end up with x times the sine of 27, okay? So if we have the sine of 27 times x, we're going to set that equal to, we just have 1 times 25, which is 25. Just as that said 3x equals 25, this is a multiplication, we have to get x by itself. So you're going to end up dividing both sides by that sine of 27, because just like anything over itself cancels out. So those are gone, and we're just left with x now. And we're going to have x equals, we're going to have 25 over the sine of 27. What we do to one side, we have to do the other. So now all we're looking at putting the calculator is this 25 over the sine of 27. So in here, make sure my calculator, I'm going to push Control Divide, okay, so I can get a fraction. And I'm going to put 25 on top. I'm checking. Oh, I am in degrees. Good. I'm going to scroll down to the bottom, and I'm going to put sine of 27. Push that trig button next to the 7 right here. And we're using sine, which is the first one that pops up. And then type in that 27 degrees, and we press Enter. And we're going to see here, round to the nearest thousands, 3 numbers. We're going to have 55. Sorry, x is approximately. I'm not going to be picky about the approximate thing. Okay, if you put equal, no big deal. We're going to have 55.067. We leave the 7 alone because the number after 2, okay, regular rounding rules, tells us to leave 7 alone. Okay. Next, let's look at here. What do we have? Here is our reference angle. Okay. It might look a little familiar because we did have this on one of the setups on the first page. I'm noticing across my right angle, I am using the hypotenuse. Let's go ahead and get that labeled now. And then the other side I'm using is on the opposite side, so it's opposite. So we find out what uses O and H, and we're back at sine still, okay, because we got O and H. So we're going to have SO in Sohcahtoa. Sine is the opposite over hypotenuse. So we set this up, we'll have the sine of the degree 59 is equal to opposite x over hypotenuse 16. The shortcut is, if x is in the numerator, you're going to multiply. N and M go next to each other in the alphabet. It's the best way I can help you. But if you notice, when we had x in the numerator up here, okay, we end up just cross-multiplying. All we did was multiply these two together. So the little shortcut where you don't have to do it all the way out with the with proportions is, if your x is in the numerator, you're going to multiply these two together. Okay, so you wind up with x is equal to, remember we want to put that in the whole number first, 16 times that sine of 59. And it looks a little weird up here. So again, with this, we're going to go to our calculator. We're going to type in 16. We're going to say times. I'm going to go to that trig button. And with sine's right there. It's the first one, sine, and I'm going to type in 59. We press Enter. And we're going to wind up with, and now this is where we got to remember our rounding rules, x is going to be approximately 13.715. That 7 after the 4 tells me to knock that 4 up 1. Okay, those are rounding rules. 5 or more, up that score. Again, pause if you need to. Moving on here. Number 4, here's your reference angle. Let's take a look at which sides I have. I do not have my hypotenuse, so I'm not using anything with H. Again, if you remember that trick I told you, there's only one that does not use hypotenuse, that's tangent. It's TOA. But here I do have my opposite, and I have the adjacent. This is why we always check our hypotenuse first, so if we don't have it, we know that the one next to it is adjacent. So again, I just told you guys, when we look up, we see opposite and adjacent. It's going to be tangent, T for tangent. So we're going to have TOA. So let's see what happens without the proportion-wise if our variable is in the denominator. Let's set up our equation. We have the tangent, T, tangent of our angle, 49, is equal to opposite, 9, over adjacent, x. When we have the denominator as the variable, we end up dividing. Denominator, dividing. You're going to switch and divide. Denominator, divide. Your x is in the denominator, you divide. So your x is now going to come to this side, okay? And you still have the 9 over here, but now the tangent of 49, they're just going to switch places. So you'll have x is now on the left, and tangent of 49 is now where x was, below the 9. Okay, so again, if you like what we did up here, the proportion-wise, please continue doing that. Okay, so again, we go to our calculator. And that's why this unit takes so long, because this video, because I have to go through the calculator and make sure you understand. We're going to have, I'm going to push Control Divide, so I get my fraction. I'm putting 9 on top. I'm going to press that trig button down here at the bottom of the screen. Trig, it's tangent. I'm going to scroll over to tangents and type in my 49. And I'm going to find out here, rounded to the nearest thousandth, x is going to be approximately 7.824. That 5 next to the 3 tells me to up that 3 up. Okay, so there's your answer there. All right, next 2 I'm going to go through pretty quickly. So buckle in. All right, keep referring to the top, the Sohcahtoa. All right, here's our reference angle right here. Okay, if you're noticing. Another thing I did was with 4, 5, and 6, they're the exact same triangles, the exact same numbers. The variable and numbers have just changed places, because I want you guys seeing there is a difference between sine, cosine, and tangent, which tells you also we're going to be using one of each. Across from a 90-degree angle, I do see my hypotenuse, okay? And then I don't have my opposite, but I do have my adjacent. So when I look at Sohcahtoa, back at the top, we're going to find out that we're using cosine. Cosine is adjacent over hypotenuse, ca. So let's set this up. We have the cosine of my angle measurement, 49, is equal to adjacent, 9, over the hypotenuse, x. I'm seeing that my x is in the denominator divide. Switch and divide. Denominator divide. So we're going to switch these 2 around. My x is going to, so I got my equal sign here. My x is going to move to the left. And then that cosine of 49 is going to move to where x was. They're just switching places. So we have cosine of 49. So then I go into my calculator. Control Divide. We have the 9 on top, but this time we have cosine of 49, not the tangent. So we're going to trig over to cosine of 49, and you see that there is a difference. The only difference between these two is that tangent and cosine, but they are different numbers. Okay? So here x will be approximately, we got 13, on the left side of the screen, 13.718. Okay, that 3 at the very end tells me to leave it alone. And let's look at the last one. Here's my reference angle. Actually, we're not using sine. I want to show you what happens now. We're switching the 9 and the x between these two. Okay, so I'm seeing here I'm using my hypotenuse, and I'm using the adjacent side. So I'm still using adjacent and adjacent hypotenuse. So I'm still using cosine. But now let's see what happens if we switch sides here. We've switched the 9 and the x around. So we're going to take the cosine of 49. This will be equal to adjacent x over hypotenuse 9. So now we see the fractions different on the left. It's a reciprocal. So now, instead of the variable being the denominator switch divide, we now have the variable in the numerator multiply. So we're just going to multiply these 2 together. So we'll have x is going to be equal to, we want to write that 9 first, then cosine of 49. So we go into our calculator, 9 times, trig button, scroll over to cosine, type in that 49, and we're going to get here, x is approximately 5.905. Okay, the 4 is bumped up by that 5 afterwards. It's kind of hard to see with the glare. Okay, there we go. All right, and that's how you solve the 5 on the missing side. It's just getting to know Sohcahtoa, what sides you have, substitute in for the formulas, and then switch divide or multiply, and you'll get plenty of practice with that.